I think what I would stress to people is no matter how the technology changes, there's always going to be this design aspect. And so I think, attorneys, project managers, they need to understand how the technology works well enough that they can design an appropriate application of that technology to a particular legal problem. Because the legal problem will not typically come in pre-canned, pre-structured in the appropriate way for machine learning. So I think that's that's much more important than understanding, how a deep neural network works. I mean, you need to understand a little about the kinds of things they get right and wrong.
Sure.
There's a lot of interest right now in things like inherent bias and some of these large language models and stuff. But I think it's much more important to understand this design process of how to appropriately use the technology. And then, of course, how to work with technical experts and things like that.
That's Dr. David Lewis, and those comments came after patiently answering a ton of my questions about the software he develops. I think Dave was politely steering me back to the things that are the most important for successful evidence management using artificial intelligence, software, and I think you might benefit from the rest of the discussion we had as well. Hey there, folks. If we have not yet had a chance to meet, I'm Chad Roberts with eDiscovery Co-Counsel. We're a law firm that helps plaintiffs' lawyers with electronic discovery in complex litigation, and it's all we do. We had some business in Chicago recently, and I asked Dave if we could drop by for an Ask the Expert session, and here's our visit with Dr. Lewis.
Hi, I'm Dave Lewis. I'm Executive Vice President for AI Research and Development at Reveal Brainspace.
Dr. Lewis, what a privilege it is. We're here in Chicago with your team of artificial intelligence engineers who work on the products you develop. And thanks very much for this chance to sit down and visit with you.
Well, thanks for the chance to geek out.
Yeah,
I'm delighted to be here.
So that's the first thing is there's a lot of basic content out there, and I just want you to feel free to go skip right over it. And this is about a deep dive.
All right, we're going deep, man.
We're going deep, man. Okay. Dr. Lewis, can you just start a little bit about your background and how you came to be in this space and wound up here with these products and the research that you do?
Sure. So I'm a computer scientist. I started my career as research faculty at University of Chicago, and I was at Bell Labs and AT&T Labs for 8 years, and then started doing independent consulting on AI. And I'd always kept my hand in the academic world. I usually had some research projects going on with faculty as well. And I was on an intelligence agency funded project on studying retrieval of scanned documents. The idea was that commandos would swoop in and capture some paper and scan it, and you'd beam it up to a satellite or something. So we're working on text analytics for that. And I needed some scanned documents. And I found that there were 7 million documents from the tobacco lawsuits that were available from the University of California, San Francisco. So I started working with that, what was a very large database at the time of scanned documents. And then I had in parallel for many years been on the planning committee for the TREC evaluations, which was a yearly information retrieval evaluation the National Institute of Standards does. And one day, Ellen Verhees, who was the head of that, came to me and said, hey, there's this guy, Jason Barron from the National Archives, and he wants to do this weird e-discovery stuff and have a TREC evaluation on it, and don't you have some kind of weird legal documents or something? So that was how I got hooked up with, as with many people, Jason Barron was my gateway drug into e-discovery, right? And so Jason and I and Doug Ord ran the first TREC legal track. I started doing consulting in that area. Eventually, I was consulting for Brainspace. They brought me on full-time as chief data scientist, and so that's how I got in.
The rest is history.
Yeah, the rest is history.
So, Dr. Lewis, I thought one of the main things we would get right into today was the issue of metrics.
Okay.
And I'm going to assume that all of our, everyone in our audience is going to be very familiar with precision and recall and those concepts, and maybe a few with the notion of F1 and what that might suggest that value of F1 in the stability of a system. And that's probably my outer limit of day-to-day use of metrics for this. Could you just maybe lay the groundwork of how you would want someone like me to have a framework of understanding of the metrics we may be using, and then the metrics that may exist in the background that are more important to the data scientists than the practitioners, perhaps, of how you measure the outcomes that your software generates?
Okay, sure. So I guess the first thing I always want to stress is that metrics are a tool, and they're only one tool that's relevant to what's essentially the legal question of defensibility, or more generally the questions of process management and whatnot, and how you carry out a review. So I wrote an article for this ABA book on predictive coding a few years ago, where I really sort of tried to stress that they're just a tool. So that's the first thing I would stress, and they're a tool that has become associated with TAR probably more than it needs to be, because the metrics themselves, things like recall and precision and whatnot, are measures of classification, sort of how well a system has done at assigning documents to categories. And those metrics are equally applicable to a Boolean query or to a TAR system or to a human review, right? So I do think in some ways they're leaned on sometimes too heavily for defensibility, but they're also thought of too narrowly, in the sense that they're not essentially associated with machine learning. They're something that can be associated with, used to evaluate any classification. So they're only one form of evaluating a classification, but they can be applied to all classifications. So I think that's another thing I'd stress. And then probably the third thing I'd stress is you never know them exactly, right? So you draw random samples and you make estimates of them. But that estimation process is essentially uncertain, and that's, when people talk about margins of error and whatnot, that's what they're talking about. But I think often people sometimes drift into talking about the recall of the system is X, rather than we have estimated the recall of the system to be X with, say, a 5% margin of error and 95% confidence.
Never losing sight of the fact that at the end of the day, this is a numbers game. I mean, this is about...
Obviously, they're numbers.
This is likelihood.
But it's an estimation game,
yes,
I think.
It's an estimation game.
It's a situation, and there are circumstances where I think people really do leap to mistaken conclusions because of not thinking about it being an estimate. So I'll give an example of that. So in BrainSpace, there's a depth for recall graph, which is essentially showing what would be your cost in terms of like how much of the top of the ranking would you have to review to hit your configured recall target, say 75% recall or something. So that's based on an estimate, and that estimate has some uncertainty. And so what you'll sometimes see in that graph is like round to round fluctuations. And we'll sometimes get people saying, "Oh my God, the recall got worse," or the depth for recall got worse, from one round to another. I say, well, there's actually variation there. It's actually pretty subtle variation, because there is a margin of error there, but the margin of error on that quantity, the margin of error on depth for recall is a trickier concept than the margin of error on recall. The qualitative thing to understand is that there are an uncertainty in these numbers, and you sometimes have to be careful not to worry too much about something that's actually just a random fluctuation.
I know at the podium in a courtroom, we often get questions that are kind of black and white questions, like what's a defensible value of recall? Right. What should it be? What standard should I impose on you, counselor? How do you practice answering questions like that when people say, "Give me the answer"? Where do I need to stop, and what's a defensible value that I need to shoot for?
Right, and we obviously one gets questions like that. The thing I always go back to is defensibility end is a legal notion, and so on the data science side, we can provide pieces of information that are relevant to that, but at the end of the day, that has to be a legal argument that's made. And so now you can, there are things that are kind of sharper edged than others. I mean, you can say, is this value computed correctly or not? This is, given this sample, this is the margin of error we have. But only, attorneys and judges can decide whether that's adequate or not, and that has to be weighed with other issues. I think I have always pushed back from the beginning against, I think there's probably a little too much settling on conventional recall targets, in the sense that different classification problems. I mean, so you have the classification problem of returning documents that are relevant to particular requests for production. That can be super easy in one situation. It might be, wow, you can get 95% recall by one keyword or something like that. And in another situation, it could be really hard to get 30% recall, super low richness, subtle category, people can't agree on what's, and that's why I get really concerned when I hear people say things like, 75% recall is standard or 80% recall is standard. So I think the data science can be informative, but at the end of the day, an attorney has to balance what data science is telling you. An understanding of what data science is telling you is proportionality and what's actually important to trying the case.
Right.
Because you may find 100,000 documents, but how many are you going to enter at trial? 10, 50, 100.
I think it's consistent with a lawyer's favorite answer, which is. Yeah. It just depends.
Yeah, well, right. It's a good data science answer too, right?
It just depends.
Yeah.
So let's just go one level beyond precision and recall, and if you could talk about the F1 and then some of the other F numbers that may be a little more refined than simple F1, and what is that notion about, and is it meaningful in sort of the everyday practical?
Oh man, we're getting really in the geek world here. So I will say, just as a little historical note, F1 is largely my fault. It was invented by Keith Van Rijsbergen in his information retrieval dissertation in the 70s, and he was my advisor's advisor. But I was on a committee for a Defense Department project on information extraction, somewhat related problem. Back when I was in grad school, actually. And I was talking to Beth Sondheim, who was the person who was organizing that project at Naval Ocean Systems Center. And we were talking about metrics for information extraction, and it was actually complicated because you have a lot of different kind of things you're doing there. And I was explaining to her about recall and precision and whatnot, and I said, well, there's these signal detection metrics, false positive, false negative rate. And basically she said, okay, well, this is all super cool, but it's the Defense Department. We need one number, and high has to be good. Right. And I said, okay, well, the F measure is like that. This Keith Van Rijsbergen's F measure, it's kind of this balance. And she said, cool, F measure it is. And that was how the F measure got into natural language processing and text classification and whatnot. And then, decades later, it ended up in like e-discovery software because we'd been using it in the research community. So anyway, that's a history. The F measure, it's useful exactly for how I described. It's like a single measure of goodness of a classifier. And so it's useful, like literally I've got one of my engineers right now, we're running some experiments where we're looking at maximum F measure on some new classifiers. And so it's useful when you want to be like studying like different learning algorithms, tunings of learning algorithms. It's not really useful terribly for e-discovery practitioners. And the reason is that we have measures that are much more directly connected to the needs of the case. So when I talk about the depth for recall graph in brain space, you always need two measures, right? You need some balance between false positives and false negatives. But arguably one of the more natural balances in e-discovery is recall versus what's it going to cost you in dollars, literally. And like we have in brain space, we've got the slider thing where you can change the cutoff and say, here's your recall, here's your dollars that's going to take, you can configure, what's it going to cost to review a document. So I think in the legal context, when you're getting around to, say, negotiating with another party or talking to the court and whatnot, I think those measures are probably more natural than a abstract measure of how good the classifier was. Because at the end of the day, we're not fielding a classifier that's going to run for the next 5 years or something. We're accomplishing a particular goal in a legal matter, and the classifier is only a means to get to that goal. So I mean, we've even talked about taking the F measure out of the UI.
Oh, don't do that.
Right?
I love,
you love it. Okay,
yeah, I love it.
You love it.
So
Okay.
what I find it illustrative of is when you're explaining to folks that there's an inherent tension between precision and recall, right?
Sure.
That you maximize one, you're going to probably compromise the other
To some degree.
and you're trying to find a sweet spot,
Mm-hmm.
and F1 can help you find a not a maximized point,
Right.
but at least it can help you go off the rails in one direction or the other.
Yeah, I think the way I would say, though, because I think the thing that is important is that the sweet spot of, say, maximizing F1 is a natural thing to do when you're studying learning algorithms. That's not typically the sweet spot in any given e-discovery matter. And one thing I really like to stress is the contextual factors are hugely important here. And this, I did some research with Eugene Yang, who was a grad student at Georgetown, is now a postdoc at Johns Hopkins. And we were looking at, suppose you have a recall target and you want to minimize cost, right? So two factors that are hugely important there are how big is the case, right? So and this is particularly looking at, like, how much training is it worth doing? Well, how much it's worth getting an incremental improvement in a classifier depends on how many documents you're applying it to. Like if your collection is 100,000 versus 10 million, if you got 10 million documents, it's worth squeezing out some additional even though somebody might look at it and say, looks like it's not getting much improvement. Well, it could be that on 100,000 documents, you're right, getting a little bit more improvement is not going to save you any money. It's going to cost you money because you have to train. If there's 10 million documents, you're going to be cost effective to do more training because you're going to pay it back by calling 100 times as many documents.
I think it's fun for folks if you've ever done, what would the F1 be for 100% precision, 100% recall? It comes out to 50. And then everything else, if I did my math right.
It doesn't always come out to 50.
Well, inverse of the sum of the inverses, right? So 1 over 100 plus 1 over 100.
Well, so think of it this way. If the classifier says yes to everything, your precision is equal to the richness.
Yes.
Right. So the precision is completely dependent on what the proportion of relevant documents in the collection is when you get to the 100% recall point.
So at any rate, it helps when you're looking at trading off. Can I spend more effort to try to increase my recall? Mm-hmm. And do I need to take some compromise on my precision, mm-hmm. Or vice versa? Mm-hmm. I don't know. I just have maybe I'm misinterpreting the metric.
I would encourage you to play with the graph and brain space where you can adjust the slider and see how recall trades off against dollars, because I think that's the best one. I mean, there have been some legal cases, a couple that have looked specifically precision, but mostly they're looking at recall and they're always looking at money, which obviously as an attorney.
The other issue that runs around is in the discussions about defensibility, and particularly a phase 1 review, or what people would call
one phase.
One phase.
Yeah.
One phase review,
yeah.
of the continuous learning.
Yep.
Is the notion of bias and
mm-hmm.
and how selective bias can play a role in that to be concerned about. We try to move folks around and spend time in the lower predictive documents and the 40 to 60 predictive documents to try to get some more discrimination built in. Is there, how have you, what are your thoughts on how to address that issue? And is there any way to see it creeping into your review without doing sampling in null sets and things like that? What are your thoughts on how best to address the concerns when people say, if you do this kind of a workflow, it's a self-fulfilling,
Okay, and so this specifically is the concern with a continuous workflow where you're reviewing the top of the ranking and you keep reviewing the top of the ranking and the potential bias.
And you never see what you never see what you don't know to look for, if that makes sense. Right.
Yeah, and so that is a concern. I mean, it tends to be less of a concern with low richness or difficult review problems, because then reviewing the top of the ranking is pretty similar to reviewing the uncertain documents. It's more of an issue with relatively high richness, because then you can sort of, as you can say, you get the self-fulfilling prophecy thing there. I tend to favor, I think, reviewing top of the ranking can be plausible in some circumstances. I tend to favor mixing that up with, so we, in Reveal, we've got in both Reveal AI and BrainSpace, we have these kind of diversity-focused active learning methods, which kind of, even more than random, will go out and pick documents that are deliberately different from each other.
So you're saying that on a good product, that kind of diversity is baked in?
That's baked into some of the active learning algorithms which have the option of using. Yeah. And indeed that comes out of, a body of research on active learning, which has explored these kind of diversity focused methods. And it's a balance between diversity and the documents that are most likely to be relevant and the documents that are most likely to improve the classifier. And so, everybody's got their special trade-off between those factors. And then as well as there's a density factor, which is sort of like, you don't want diverse training documents that are just like weird documents that are like nothing else. I mean, yeah, it's super diverse. It's like the one Russian document in the collection or something, but it won't help the classifier. So actually we, like in BrainSpace, we use a variant of K-means ++, which kind of balances this diversity and similarity to other documents. So yeah, I think this is something that it really is helpful to the tools that are built into the modern software there.
So people should have more confidence that with a good product where that conscious diversity is baked into the to the queue of things to see next.
Yeah, and it's there's nothing wrong with a top ranked review either. But it's a good idea to do at least a little bit of the diverse stuff. The argument, of course, for reviewing from the top is you want to get done as quickly as possible, right? And so you want to look at the stuff that's most likely to be relevant. It's just then that has to be balanced against potentially trying to improve the model to find things that aren't being found. And this is actually, it's a classic dilemma in an area of machine learning called reinforcement learning, where this is kind of the fundamental problem. It's called the exploration-exploitation trade-off. How much do you learn and how much do you take advantage of what you already learned? And this, all algorithms in this area have to balance those two factors.
So is it urban legend then that I should be spending as much time as I do in the 40 to 60 with the self-perception that accelerates the hourglass shape you see what I'm saying?
Yeah, I mean, that's not a bad thing to do. It's because I want to, while I think I would probably bet on my active learning algorithm versus you going in and pulling from 40 to 60.
Nothing personal, but I get it.
But on the other hand, there's other contexts too. I mean, you may have a standard process in your organization where you've promised the other side you're always going to review everything down to a certain score level, right? There can be reasons for sometimes people will choose from sample from score bands, partly to accelerate training, but also partly to just have a characterization of what does this ranking look like. Say, they may have reporting requirements to an adversary, or it may just be for process control. You're going to be batching stuff out to different people, and you want to, sort of predict how long is the project going to take, because so there's more to this than just what, say, a machine learning scientist would say is optimal.
A lot of it is our sense of learning your data set, and
sure.
Even on humongous data sets,
right,
you can get pretty intuitive about it pretty quickly. There's so much repetitive content. Somebody's on a spam list, and you're seeing the same things over and over again, and you're starting to think, okay, this is why it's 0 to 10. I get it. Right. This is the kind of junk down here, and it helps when you're on the phone with opposing counsel of being able to say, I'm familiar.
Right. Indeed.
I'm
exactly.
familiar with what's in 0 to 10. Just relax. It's his weekly menu from the restaurants, and all that just kind of
that's a perfect example of, you have needs in the legal context which are beyond the purely machine learning needs.
I'm with you. Yeah. What for a young lawyer who has this as their responsibilities and is working with this, what do you see what's coming down the pipeline for them? What kinds of skills might they invest in that would be of benefit for the rest of their legal careers? And what kinds of new applications and technologies do you see heading down the pipeline for them to have to get their arms around in the future?
Wow, that's a big question. I'm hesitant to be giving advice to attorneys. I guess what I would say on their careers, that is, I give advice to attorneys all the time. But I guess what I'd say is, the technology will change, but a lot of the basics. I mean, we talked about evaluation, workflow design. Issues of data modeling are I think a big thing I always like to stress is these machine learning technologies do what we tell them in what I mean by that is, just to take a classification problem, you have to decide what the classification problem is. And I think sometimes, people think e-discovery is, all right, you get in an RFP, and the RFP defines what yes and no on a classification problem is. And I mean, you can do that, but it's often not a good idea, right? I mean, you may say, okay, part of the RFP is only the documents between 2017 and 2019 are relevant. Okay, that. You don't need to teach the machine learning algorithm that. Just go to the metadata field and use that metadata field to do the date. Okay, and then maybe there might be, classes of documents. Maybe there's like images or something. Okay, they're not going to go into the same pipeline the textual documents are. I mean, we're now getting to the point where you may be able to use machine learning even on the images, but you won't use it in the same way you use machine learning on the text documents. So maybe you have some bifurcated workflow there. And so the thing I would, I remember early in e-discovery when people were still getting their heads around even the notion of machine learning, you sometimes hear, I've had attorneys, say, I would start talking with them about cutoffs and recall and precision. And they would just say, well, the machine decides. I say, no, the machine doesn't decide. You set up the problem and you calibrate, how you're going to apply machine learning to it. Another thing is that, you may define, sure, there's this RFP. Maybe the RFP has 17 requests in it, and, 13 we're actually going to handle by some other process. And then the remaining 4, Okay, for those four, well, those four really, we should break it down into 7 different categories and build 7 classifiers. And so there, I think what I would stress to people is no matter how the technology changes, there's always going to be this design aspect. And so I think, attorneys, project managers, they need to understand how the technology works well enough that they can design an appropriate application of that technology to a particular legal problem, because the legal problem will not typically come in pre-canned, pre-structured in the appropriate way for machine learning. So I think that's I think that's much more important than understanding, how a deep neural network works. I mean, you need to understand a little about the kinds of things they get right and wrong.
Sure.
There's a lot of interest right now in things like inherent bias and some of these large language models and stuff. But I think it's much more important to understand this design process of how to appropriately use the technology. And then, of course, how to work with technical experts and things like that.
So taking the textual description of documents in an RFP
Right.
and translating that and building a good workflow.
Right, and understanding, what is going to be an easy thing to train a model to do, what's something you shouldn't use a model for at all, what's going to be hard. That kind of problem. We're working on a series of courses on model building right now. We do a bunch of online training courses and things, and that's one of the things we've been talking a lot about is that design process and how to teach it to people.
Cool. Dr. Lewis, we've probably hit the point at which even the hardcores have so Saturday morning 1 cup of coffee kind of a thing. Thanks so much for letting us.
And I could go all day, but yeah.
Thanks so much for letting us crash your workday here in Chicago and spend some time with us. And we follow your work and your publications, and we just appreciate it. Thanks again.
Well, thanks so much, Chad. This has been absolutely delightful.
All right. See you next time.
Thank you.